Hi guys, welcome you all to my channel Explore Edu to Teach. The next important topic in signal and systems that we'll be covering today is Fourier series. The Fourier series is one very important part of signal and systems, and it plays a very important role in your competitive exam, in your university exams, not only in case of engineering but also in case of your 11th and 12th grade. This is a very important topic. So we'll be talking about this topic today. We'll be learning about Fourier series, especially the trigonometric Fourier series, the type of classification of signals, and everything. So just give you overview of the topic before diving deep into it. So we'll be talking about what is a Fourier series, what is the expression, trigonometric expression of a Fourier series, then what are the terms A0, AN, BN, how do you classify signal like even symmetry, odd symmetry, half wave symmetry and quarter wave symmetry. So by classifying signal, how can you reduce the expression to the lowest possible form? Then we have numericals in order to classify the signals which are there. And then we have solved one particular question in which we have given a periodic signal x of t and we have to find out the trigonometric Fourier expansion for the signal. So I hope I am very clear with this. So we'll try to solve a numerical on it and then go ahead accordingly. So starting with the Fourier series now. If you haven't subscribed to my YouTube channel, I request you to kindly subscribe to my YouTube channel. Follow me on Instagram. The links are given down in the description box also, because there are regular updates posted on Instagram also. Different formula, everything is posted on Instagram which will help you in your studies. So do follow me on Instagram. My channel is Explore Edu to Teach, and let's dive into the topic. So talking about Fourier series, so the first topic is a representation of the signal. So basically any electrical circuit, okay, gives output in the form of voltage or current. The voltage is basically given by Thevenin's theorem and current by Norton's theorem. So basically I can say a signal can be in two parts. Basically this continuous and the discrete, the periodic and the non-periodic. All this classification of signal is given in my introduction video. If you haven't watched it, please check it in the signal system playlist in my YouTube channel. You'll get it over there. It's a basic part of the video. Do watch that video out because that will give you a basic understanding of this subject. Once you have an understanding, then dealing with all the topics will be easier. So talking about Fourier series is basically a mathematical technique in which the periodic signal will be decomposed into sine and cosine term. So what are the very important terminology in a Fourier series? The Fourier series is basically a mathematical technique for periodic signal. So to define a particular Fourier series, you need a periodic signal first, and then that can be decomposed into sine and cosine terms. So if you look at the expression of a Fourier series, you'll have A0, which is a constant, you'll have cosine terms and you'll have sine terms. So basically a periodic signal x of t can be written in the form of a constant A0 and periodic coefficients an and bn, where an goes from 1 to infinity, your bn goes from 1 to infinity, and you have cos n omega naught t, sin n omega naught t, where n value is given from 1 to infinity. Hence, I can say basically a Fourier series is nothing else than a mathematical technique in which my periodic signal x of t, or any signal will be a periodic signal, can be decomposed into a constant value and into sine and cosine terms, wherein you have your n value going from 1 to infinity, omega naught as 2 pi f, where f is the fundamental frequency. The next thing is, now what are these values in this term, right? You have come across different values. What are these values? N omega naught is the harmonic frequencies. A0, An, Bn are the trigonometric Fourier coefficients, wherein your A0 is given as 1 by t integral 0 to t x of t dt, wherein t is the time period of the signal. Your An is given as 2 by t integral 0 to t x of t cos n omega naught t dt. Bn can be equal to 2 by t integral 0 to t x of t sin n omega naught t dt. Now this dt can be equal to d omega t also, depending upon the reference x-axis scale given to you in the question. if your x of t time scale is given in terms of omega t, you can define here as d omega t. If it is given in terms of just t, it will be dt. So basically a periodic signal can be decomposed into a constant a0 and an bn with cosine and sine terms. So in that, your a0 is given as this and your an and bn is given as this. The formulas have to be very clear to you. Don't worry right now if you're not able to get a complete understanding of it. Do watch the video till the end, because as I told, we'll be solving a numerical on it, wherein this particular signal will be given to us and we'll be trying to find out the Fourier series expansion for the same. Post this, we'll be having the Fourier coefficients. Okay, as I told you, we have three Fourier coefficients, that is a0, an, bn, right? So in this, what happens is that if you understand the kind of signal given to you, then you can directly reduce the particular signal into some smaller format. For example, you have basically a even symmetry signal. I'll be talking about what is a even symmetry or symmetry later, but if it is an even symmetry signal, my bn coefficient is directly equal to 0. So your work is to just find out a0 and an. Similarly, if it's an odd symmetrical signal, your a0 and an is directly equal to 0 and only your bn will exist. So that is very important. What happens is, as I told you, if you are able to identify the type of signal given to you, you need not solve the question for each and every coefficient by applying these formulas as a0 as this, an as this and bn as this. You directly know that if it's an even symmetry, my bn will be equal to 0. I just need to find out a0 an. If it's an odd symmetry, my a0 an is equal to 0 and only my bn will exist. Similarly, if it's a half wave symmetrical signal, now as the name suggests, it's a half wave symmetrical, that is for a time period from 0 to t, it's going to be half wave in the positive axis, half wave in the negative axis, and it's going to be symmetrical to each other. In that case, my a0 will be equal to 0 and only my an and bn will exist. Similarly, I have my quarter wave symmetry. In case of my quarter wave symmetrical signal, basically a quarter wave symmetrical signal is a half wave symmetrical signal which is also combined with either even or odd. That means I can divide my quarter wave symmetrical signal as half wave symmetrical plus even symmetry, half wave symmetrical plus odd symmetry. So if it's a half wave symmetrical with even symmetry, you know that in case of my even symmetry, my bn is equal to 0. So my bn will be equal to 0. And since my half wave symmetry says that my a0 will also be equal to 0. So since it's a combination of half wave plus even symmetry, my a0 is 0, bn is equal to 0 and only my an will exist. Similarly, if it is a half wave symmetrical signal with odd symmetry, what happens is that you know that a odd symmetry means a0 and an is always equal to 0. Half wave symmetrical means that a0 is equal to 0. That means only my bn will exist. Hence, if you understand the kind of signal which is given to you, if it is even, odd, half wave symmetry or quarter wave symmetry, you can directly find the value or direct the values of few of the coefficients like a0, an, bn to equal to 0, and you can find out the remaining coefficients so that you can save on time and the sum can be solved very quickly. So I hope I'm very clear. So talking about Fourier series, just to give you a review, it's basically a mathematical technique in which my periodic signal, like in this case x of t, can be decomposed into a constant value and into an and bn, which are basically my Fourier coefficient signal in terms of my cosine and sine terms. My a0, an, bn formula are given over here, and I have my even symmetrical signal in which my bn is equal to 0. Odd symmetry is my a0, an is equal to 0. Half wave symmetrical signal, my a0 is equal to 0. And when I talk about a quarter wave symmetrical signal is always that signal in which I have half wave symmetry plus even or half wave symmetry plus odd. So if half wave symmetry plus even, only my an will exist, because if I talk about half wave, my A0 is 0. If I talk about even, my Bn is equal to 0. So combining this, only my An will exist. Half wave with odd, my half wave says that my A0 is equal to 0. My odd symmetry says that A0, An both are 0. Hence my only Bn will exist. Okay. So let's try to classify some of the signals and then solve a numerical on it. Fine. So the question says classify the following signal into the different form of symmetry that they exist. So if you see over here, the x of t is given to you, and I find that what is there in the positive half, the similar pattern is there in the negative half as well. So it's like a mirror image, right? The positive half is a mirror image of negative half, or the negative half is a mirror image of positive half. In that case, it's an even symmetrical signal. There is no half wave symmetry because my signal doesn't exist in the lower amplitude scale itself. Hence, I have only even symmetry. Similarly, if I consider this signal x of t, which is again a periodic signal, in this what happens is that my positive side of the axis of signal and the negative side also axis of signal is there. So it's a odd symmetry, right? Because if you see over here, 0 to t by 2 had positive value, 0 to minus t by 2 also had a positive equal value. Hence it was an even symmetry. But here if you see 0 to t by 2, it has a positive value, and 0 to minus t by 2 also has an equal positive value in the negative amplitude. Hence it is a odd symmetrical signal. And talking about half wave symmetry, yes, it is a half wave symmetrical signal also, because 0 to t by 2 it is existing in upper half, t by 2 to t is existing in negative half. Hence we have half wave plus odd symmetry also. So I hope I am very clear with this. Now, so what happens is that when you get this signal, if even symmetry, I can directly say that my Bn coefficient is equal to 0, hence my only A0 and An will exist. If I just see this signal, I know that it's a half wave symmetrical signal. So in that case, I know one thing for a matter of fact, that my half wave symmetrical signal says that A0 is equal to 0. Odd symmetry says that A0 An is equal to 0. Hence for this signal, had I to find out the trigonometric Fourier expansion, only my Bn term would have existed. A0 An wouldn't have existed. That is what we proved in half wave with odd symmetry. Now we'll talk about the next thing, solving a question on the same. To find the trigonometric Fourier series of the waveform given. So here if you see, I have signal x of t given to me. Now from this signal, I cannot determine anything, right? Even symmetry and for odd symmetry, there has to exist something in the negative half. They have not given anything in the negative half. Hence I cannot determine whether it's an even signal or odd symmetry signal. Next thing, also nothing is given in the negative half of the amplitude. Hence I cannot even say that it's a half wave symmetrical signal. So in this case, I can definitely say that I cannot determine whether it's which kind of signal. So I have to write down the signal expression and find out each and every term like A0, An and Bn. Had my signal been given in the negative time scale, I would have determined whether it's even or odd symmetry. Had it been given in the negative amplitude scale, I would have told it's a half wave symmetry. But since here nothing is mentioned, I cannot classify the signal that way, and I have to find out A0, An and Bn, everything. So in case of my A0 says 1 by t. I have already written the formulas over here. You can make a note of it. The notes are present in description box of this particular video. Please download it from there and share it to as many people as possible. A0 is equal to 1 by t integral 0 to t x of t dt. So you have 1 by t integral. If you look at the signal, it's only from 0 to t by 2. From t by 2 to t, it is 0 value. Again, from t to 3t by 2, it's just a periodic signal. So since I'm talking about a periodic signal over here, I will just consider from 0 to t, because after t, again the signal repeats itself. Again after 2t, the signal repeats itself. Therefore, I just consider from 0 to t, because post that it's just a periodic signal. So I'll just consider a0 is 1 by t integral 0 to t x of t dt. So 1 by t integral 0 to t by 2 x of t is a dt plus t by 2 to t 0 dt, because from t by 2 to t there is no value. Hence my a0 is equal to a by 2. My an is given as 2 by t integral 0 to t x of t cos n omega naught t dt. So 2 by t integral 0 to t by 2 x of t is given as a, right? In from 0 to t by 2, my x of t, okay, the term here, the a value is missing. The amplitude is given as a over here. Okay, it's missing over here. Please assume it that 0 to t by 2, the value is given as a. So we have x of t as a cos n omega naught t dt. Now it's a normal integration in which a is a constant, so it is removed out. The integration of cos n omega naught t is given as sin n omega naught t upon n omega naught 0 to t by 2. Again n omega naught is a constant, so I am removing it out. Hence I have 2 into a upon n omega naught t. Sin n omega naught t is given as, n is given over here, omega naught is given as 2 pi by t, and my t value is given as t by 2, and my t value is also given as 0. So I'm just applying those values over here, and I get the final answer because sin n pi is equal to 0. Hence my value is equal to 0. Now after this I have my bn. The bn is given as 2 by t integral 0 to t a x of t sin n omega naught t dt. So x of t is given as a. So I'm taking 2a by t as constant. Sin n omega naught t, again you have to integrate it as minus cos n omega naught t upon n omega 0 to t by 2. N omega naught is a constant, so that comes out, you have 2a upon n omega naught t, and minus cos n omega naught t 0 to t by 2 is given. So just put the value of t as t by 2 and this t as 0. Now cos 0 is given as 1, and omega naught, I told the value, omega naught value is always given as 2 by t. So you can just put the value as omega naught as 2 by t. So just put those values. Cos n pi is given as minus of 1 raised to n, and just try to find the final answer. Hence my a0 is basically a by 2, an is 0, and bn is given as this value, a upon n pi minus of minus 1 raised to n plus 1. Hence my x of t is given as this. Therefore whenever a signal is given to you, just see whether you can classify it in any other kind of signal, so that some of the coefficients can be directly given as 0. But since in this signal I cannot classify it as even or odd, because the negative half value in terms of time scale is not given, and neither I can classify it as half wave symmetry, so that I put a0 as 0, because my negative amplitude direction is also not given. Hence I have to find out all the three signals, three coefficients a0, a and bn, and I get the final answer. So I hope I am very clear to you. I have tried my best to explain you all the concept. If you understood it, please do not forget to like, share, subscribe to my YouTube channel, follow me on Instagram, share it to as many people as you can, who you can feel can get benefited out of it. So thank you so much guys. God bless you.